Professor, you say it was an unsolved problem and it remains unsolved, how hard it is. How can you solve how hard something is? That just seems like a subjective thing, like it's very hard or it's very, very hard. What's to solve about the hardness of it?
Yeah, so when computer scientists look at problems, they say, how hard is this problem? And the answer is, hopefully often, for most problems, that it's solvable and quickly, in a feasible time, so that you have a fast algorithm. So you answer the question of how hard the problem is by demonstrating that you can solve it quickly. Just like primality testing is quick, we need that with RSA. So that's a solved problem. We know how hard it is to find out whether a given number is prime or not. But to factor, we don't know. We don't have good algorithms. So it might be hard. We're still woefully ignorant in computer science about lots of things. There's lots of problems that we think are hard, but we have no way to prove that they're actually hard. So I think we're many decades off from trying to actually demonstrate that these problems are in fact hard. What does hard mean? So typically for a computer scientist, hard means that the difficulty goes up more than polynomially with the length of the input. So with the product of two primes, if you've got a 100-digit number, and you expand that to a 200-digit number and try to factor that, you'd hope that the difficulty goes up, say, exponentially with the increase in the length. So that's the typical way that a computer scientist thinks about these. It's not a difficulty of a particular instance, but how fast it scales in difficulty.
People watching at home will be screaming at their screens for me to ask about quantum computing.
Yes, quantum computing.
How does Mr. RSA, or Mr. R in RSA, feel about quantum computing?
So quantum computing seems to be coming along. People keep working on it. There's quite a bit of money involved in the research side of things. I would love to see it fall flat on its face and not work at all. It would be the demise of RSA should quantum computing happen due to an algorithm, due to Peter Shor, which shows you how using a quantum computer you can factor large numbers efficiently. So quantum computing, if it works, will mean big changes in cryptography. Not only RSA, but lots of other things will need to change. And people are working furiously on that as well, because it seems not impossible, not implausible that in a couple of decades we could have good quantum computers around. Who knows? As I said, I hope it doesn't happen. What
is it about quantum computing that will break this problem?
So quantum computers are great at finding periodicities. So if there's some unknown system with a large period, a quantum computer can find that efficiently. And that's really what Peter Shor's algorithm did. And RSA is all about periodic functions, raising to powers and taking remainders. These functions have periodicities that a quantum computer can find, and those tell you the P's, the Q's that you need to do to break the system. So quantum computer is ideally suited for breaking RSA. It's not clear what else it's suited for. It's hard to find other applications of quantum computers, actually.
Surely someone who loves technology and just loves knowledge and progress would find some joy in quantum computers coming to existence, or are you?
Well, I'm all in favor of the truth wherever it lies. So I mean, if quantum computers are feasible and workable, so I can live with that, and we can go on and do other things. But it would be, as a co-inventor of RSA, it would be a shame to have to put that to rest due to quantum computation.
Again, people watching will be screaming at me to at least ask you, do you think quantum computers already exist? Have the CIA got one? Has Russia got one?
Very small quantum computers do exist. People have factored small numbers using these ideas. 15 was factored a while ago. So they're the foothills of doing larger things. We'll see where it goes.
You don't think that hidden in some vault somewhere someone's got one that's breaking all their credit cards?
I doubt it. I doubt there's things hidden in the vault. I don't know. I don't have a security clearance. I don't have any special knowledge, but things that happen in intelligence agencies tend to be a few years ahead, but not decades ahead of what we can do in the real, outside of the classified world. So,
what's it like being a co-founder, a co-inventor of something that is so commonly used by so many people on Earth? Like, what feeling does that give you?
It's nice to see that it adds value to what people are doing, that it's actually turned out to be useful. There are risks in this too. I mean, I've worked on other cryptographic systems that have had wide use and have fallen apart. MD5 was a hash function that I invented a while ago, and it turned out there was a flaw in its design that got widely used, and then it was broken. So by Xiaoyuan Wang and others. So there's a risk in getting systems out there that are widely used, because we don't in cryptography actually know how hard some of these problems are. As I said earlier, they could be breakable. So you do the best you can, and you hope that they're there, and we're developing better techniques for developing secure systems. RSA seems to have stood the test of time pretty well, and quantum computers may, however, in the end, be its downfall.
Does that mean doing the work you do, like, is giving you sort of joy because you've invented things, or is it a constant burden? I know, am I going to be responsible for the next big problem, the next big hack, is this a burden more than a blessing?
Certainly, there's both sides of that. It cuts both ways. Any kind of technology can be used for good or for evil. Any kind of technology in the crypto side can be broken, perhaps. So you have to worry about all those things. And you work with standards committees. You work with companies developing software and so on too, to try to make sure they use best practices, whatever the best practices are of the day. But that evolves.
So a lot of people are quite ignorant about the importance of cryptography. Do you walk around looking at a world dependent on cryptography like warmly and with happiness, or with a kind of a nervousness knowing that it's some kind of house of cards that we're living on? How do you feel about it when you look at it through your eyes?
I think the crypto part of the security picture is really quite strong. We have good cryptography. Their schemes are well studied. They're unlikely to be broken casually or quickly. We have much more problem in the security world with computer security, your smartphone security, your PC security. Those are much more fragile, much more vulnerable, and most of the security hacks that we see happening these days are not due to weak crypto. They're due to people getting around the crypto by breaking passwords or breaking into computer systems somehow.
Do you think there is sufficient knowledge and understanding of cryptography in the world? Does there need to be? Like, is it something we don't need to worry about, or would you like to see greater understanding?
I think greater understanding of security in general would be great. There's a lot of people who put out products that they don't think that the system, they don't even think about the possibility that their system might be attacked. People are putting out smart refrigerators that get used as part of botnets and send spam everywhere and do denial of service of attacks. These things need to be thought through from the beginning as being something that might be subject to attack.
The thing I wanted to talk about today is the coolness that is public-private key cryptography. The basic idea of how it works, I think, is just cool. It's such a clever idea that I wanted to explain it.